So let us clear the board and talk about another topic, zeros or zero of a polynomial. Zero of a polynomial. Then we will go back to the graphs and we will discuss the graphs in great details. So don't worry about it. Zero of a polynomial. Zero of a polynomial is such value of x for which f of x becomes 0, right? So if I write, let us say, a linear polynomial like this, x minus 5. So can you tell me what will be the 0 of this polynomial? 0 of this polynomial will be obviously 5, x equal to 5, because when I put x equal to 5 here, then 5 minus 5, that is f of 5 is equal to 5 minus 5 equals 0. So 5 is the 0 of this polynomial, okay, and it is a linear polynomial. There can be maximum 1 0, right? Maximum one value that can make it 0. Or let us say we have got an expression like this, x minus 1, x minus 3, and it is f of x. Now this is another polynomial. This polynomial will become 0 at x equal to 1, because when I put x equal to 1, this bracket will become 0, and 0 into something is 0. So f of 1, if I say, is 0 into 1 minus 3, that is 0. Similarly, f of 3 is also 0, because f of 3, that is x equal to 3, will make this bracket as 0. Now zeros of this polynomial are 1 and 3, okay. All right. Now for linear polynomial ax plus b, let us say f of x equal to ax plus b, the 0 of this polynomial will be a value of x that will make this expression as 0. So you can work in the reverse manner also. You can put it equal to 0 and find the value of x, that is minus b by a. So the 0 of this polynomial is minus b by a, or what you can say is f of minus b by a is equal to 0, okay. If you look at it graphically, then you can say that for this value of x, y is 0. Or if I draw a graph of ax plus b, that is, it will be a linear graph because it is a linear expression, right? Now what will be this point here? It is the value of x, that is minus b by a, where y becomes 0. We know that every point of x-axis, at every point of x-axis, the y coordinate is 0. So this is the point that tells me if I put minus b by a in place of x, it will give me 0. Or another way of thinking about it is, wherever the graph cuts x-axis, that x value is the 0 of that polynomial, okay. We will discuss about graph of quadratic polynomial in detail. Before that, let me tell you about zero polynomial. This is another polynomial. For example, let us say I've got a polynomial ax square plus bx plus c, right? And let me write p of x equal to ax square plus bx plus c. Now I have not said anything about a, b and c. Values of a, b and c can be anything. Let us take a case where a equal to b equal to c equal to 0. So what will be the value of this polynomial? This polynomial will be 0 itself, right? Such polynomials are known as zero polynomials. So if I simply write this 0, this is a zero polynomial, okay. P of x equal to 0 is a zero polynomial, or you can say y equal to 0. Now we have seen that wherever the graph cuts x-axis, it gives me 0 of that polynomial. And what can you say about y equal to 0? It is the entire x-axis. So every point on this x-axis is a solution or is a 0 of this polynomial. So how many zeros, if you say zero polynomial cuts the x-axis at infinite points, right? So what will be the degree of zero polynomial? Degree of zero polynomial is not defined. Degree of zero polynomial is not defined, right? Because it cuts the x-axis, or it is the x-axis itself, right? It meets the x-axis at infinite points, so it is not defined. Linear polynomial cuts the x-axis at one point, so its degree is 1. A quadratic polynomial cuts the x-axis at maximum 2 points, its degree is 2. Okay, zero polynomial degree is not defined. Now let us move to next topic, general form of an nth degree polynomial. So if I have to write nth degree polynomial f of x in its general form, I can write an x raised to power n plus an minus 1 x raised to power n minus 1 plus an minus 2 x raised to power n minus 2, and so on. The powers of x will keep on decreasing and ultimately it will become 0. But before that, let us say x here, it will be ax, and the last term let me write as, I have started from an, so the second last term will be a1x, and the last term will be a naught. And we can write x raised to power 0 here, or x raised to power 0 is 1. So this is the general form of an nth degree polynomial, and you need to take care that for it to be of nth degree, it is necessary to mention that this coefficient here an is not equal to 0, right? Because if it becomes 0, then the highest power of x will no longer be n, right? For it to be of nth degree, an should not be equal to 0. Now let me tell you the terms that we use here. These are coefficients, right? This is a coefficient of x raised to power n minus 1. Okay, and these powers, these powers, all of these are non-negative integral powers. Non-negative integral powers. So I stopped at x raised to power 0 here, right? I cannot write negative powers, then it will no longer be a polynomial. So these are coefficients, but this coefficient here has got a special name, that is leading coefficient. Leading coefficient. Why? Because it is with the highest power of x. Highest power of x here is n, so it is the coefficient of x raised to power n here. That is why it is the leading coefficient. And these are terms. This is one term, this is second term, this is third term, right? These are terms. So how many terms are there in this polynomial that I have written here? So you started with n and you went up to x raised to power 1 and then x raised to power 0. So if you count these terms, these are n plus 1 terms. These are n plus 1 terms, right? Only if the these coefficients are non-zero, right? If let us say one of these coefficients becomes 0, if this coefficient becomes 0, then this term will vanish. This term will no longer be there. So when I comment about the number of terms without talking about coefficients, I can say that there can be maximum n plus 1 terms, right? Maximum. Why? Because when all these coefficients are non-zero, then the terms will be n plus 1. Number of terms will be n plus 1. Otherwise, it can be lesser number of terms. Because for it to be of nth degree, I can take, let us say, I take f of x equal to an x raised to power n. This is also an nth degree polynomial. It has got just one term, right? It has just got one term. And this polynomial was also nth degree polynomial with non-zero coefficients, and it had n plus 1 terms. So maximum number of terms can be n plus 1. Otherwise it can also have one term, or this is also an nth degree polynomial, right? If these two coefficients are non-zero, then it has got two terms. It can have three terms. So maximum it can have n plus 1 terms. Okay, and when all these coefficients, let us say, I write it once again. Let us say I've got f of x equal to an x raised to power n, an minus 1 x raised to power n minus 1, and so on till a1x plus a naught. Okay, all right. Now if all these coefficients are 0, right, all the coefficients, if these coefficients are 0, then what will I have on the right hand side? I will have 0. Then this polynomial is known as zero polynomial. Okay, so what is the degree of this polynomial? It is not defined. Because you can from the layman's perspective, you can see that 0 can be written as x raised to power 0 into 0, 0 into x raised to power 1, 0 into x raised to power 2, and so on, right? So its degree is not defined. It hasn't got a unique degree. Okay, so its degree is not defined. Otherwise we also interpreted it graphically, that when f of x is equal to 0, it means we are talking about x-axis itself. So its graph is x-axis. Okay, so at every value of x it will be 0. That means it has got infinite x values where it will be 0. That means the degree is not defined.